Welcome to Finite Math, Notes 3.2b and 3.2c. So last time we kind of left number 16 waiting. So if you figured it out, congratulations. Otherwise, here's how we look at it. So secant squared and cosecant squared, again, we can oftentimes turn these into terms of sine and cosine. So if you wanted to say 1 over or 1 divided by 1 over the cosine squared of x plus 1 over or 1 divided by the sine squared of x, you could turn that into that format. And all of that should still equal 1, because remember, you're only allowed to change one side of an equation to prove an identity. If we wanted to show the fraction math, 1 divided by 1 over the cosine squared of x plus 1 divided by 1 over the sine squared of x equals 1. And when you divide by a fraction, you multiply it by the reciprocal. So we have 1 times the cosine squared of x over 1 plus 1 times the sine squared of x over 1 equals 1. And 1 times anything and then divided by 1 is still just the anything that we had. So we have the cosine squared of x plus the sine squared of x equals 1. And again, that's one of our main Pythagorean trig identities. And again, identity means something equals itself. So we should end with 1 is the same as 1. Going further into 3.2c, we'll probably do the next 2 here and then pick up for the rest for the back page in the next video. But we have for number 18, 1 over 1 minus the sine of r equals the secant squared of r plus the secant of r times the tangent of r. So one way that we can deal with things like this, again, this looks like an a minus b situation. If I wanted to get rid of that 1 at the bottom, maybe 1 plus sine squared, or sorry, 1 minus sine squared equals cosine squared. So we might multiply by the conjugate here, multiply by 1 plus the sine of r. And again, to change the denominator, we would also have to change the numerator, 1 plus the sine of r. So we get 1 times 1 plus the sine of r is just still 1 plus the sine of r. And remember, we are using the rule that a plus b times a minus b can always equal a squared minus b squared. We can factor or we can multiply pretty quickly that way. And again, our a is 1 and our b is sine. So we have this over 1 minus the sine squared of r, which again is one of our trig identities. We know that that is going to become a cosine. And all of this will equal the secant squared of r times the tangent, plus the secant of r times the tangent of r. So we can turn this again into 1 over the cosine squared, 1 plus the sine of r over the cosine squared of r. Still equals the same stuff on the other side. Now with fractions, when you're adding or subtracting in the top of the fraction, you can actually break this into 2 separate fractions using the same denominator. So 1 over the cosine squared of r plus the sine of r over the cosine squared of r can now equal the secant squared of r plus the secant of r times the tangent of r. And 1 over the cosine squared is the secant squared. We just need to change the sine over cosine squared into a secant tangent. But we can already set the secant squared of r plus. Now, how to turn this into a secant times a tangent? Well, a cosine squared is cosine times cosine. So we could make this into 1 over the cosine of r times the sine of r over the cosine of r. we're kind of unsimplifying that a little bit because 1 over the cosine of r is the secant of r, and sine over cosine is the tangent. Bleeding over into number 22 a little bit, but that's okay. But now, again, because it's an identity, we need to finish with the statement that the secant squared of r plus the secant r times the tangent of r equals itself. And you might have noticed through these videos, let's move this again out of the sun a little bit, that we're not boxing an answer at the end because the answer is a proof. It's every step along the way. So these are really problems where you should not be skipping steps. You need to be very explicit about what happens and where ideas come from. Such as in number 22, which we could do with factoring or we could do with foiling. I'm going to choose to work with just the left side and do foiling. So we need to turn 1 plus the sine of x over 1 minus the sine of x into 2 times the secant squared of x plus 2 times the secant times the tangent of x minus 1. So again, I'm going to change the base because 1 minus sine isn't squared, so I can't turn it into a cosine yet. But one of the tricks that we often use is to multiply by 1 plus the sine of x. But again, we're going to have to change that in the top here. We could have just said 1 plus the sine of x squared now, or I'm going to mark it to help me do my double distribution in a moment. Because 1 times 1 is 1, plus 1 times the sine of x is the sine of x, plus another sine of x would be 2 times the sine of x, and then the sine of x times itself would be the sine squared of x. All of that is going to be over 1 minus the sine squared of x, because again we're using the difference of squares rule in order to create something that I can turn into a cosine. And again, all of this still equals 2 times the secant squared of x plus 2 secant tangent plus 1. All right. Again, we said that we can turn this into a cosine. So 1 plus 2 times the sine of x plus the sine squared of x over the cosine squared of x is going to equal negative 2 times the secant squared of x plus 2 times the secant times the tangent of x plus 1, or sorry, minus 1. Minus 1. So once again, we can split up addition and subtraction in the numerators, tops of fractions, just using common denominators. So we have 1 over the cosine squared from the 1 up here, plus 2 times the sine over the cosine squared, which we saw in the previous problem. Looking over here, we turned sine over cosine squared into 1 over cosine times sine over cosine. That's where we got our secant tangent, which we will need in a second. Plus the sine squared of x over the cosine squared of x. All of that is going to equal 2. This shouldn't have been negative. That's just a 2. Times the secant squared of x plus 2 secant tangent plus 1. So again, 1 over cosine squared is already a secant squared. And we saw that sine x over cosine squared x could become 2 times 1 over cosine x times sine x over cosine x And sine squared over cosine squared can become tangent squared of x. And we are going to equal everything that's above it. So we'll clean this up a little bit. I turned this into a tangent squared because a tangent squared could be another secant squared minus 1, and we need the minus 1, and we need another secant squared. So the secant squared of x plus 2 times the secant from the 1 over cosine times the tangent from the sine over cosine plus, and this tangent squared becomes 1 secant squared minus 1. Sorry, I had to look at the rule. And that equals all the stuff that it was supposed to be above. But again, we don't need the parentheses really. I was just trying to highlight the tangent because we're just adding. We're not going to distribute or multiply or anything. So secant squared plus another secant squared is 2 times the secant squared. We already have our plus 2 secant tangent. And we are subtracting 1. And again, our final step in an identity is showing and proving that it equals exactly itself. And we'll pick up in the next video.